Welcome back. In this video, I'm going to be focusing on weak pointers. A weak pointer does not control the lifetime of an object in memory, and a weak pointer is usually bound to a shared pointer. Whenever you create a weak pointer, it does not really increase the reference count, as is the case with a shared pointer. So you may have multiple weak pointers pointing to an object in memory, which is also pointed to by the shared pointer, but you will not see the reference count increasing as and when you keep increasing the weak pointers pointing to that object. So let's see how we can initialize a weak pointer. So you start off by creating a shared pointer as using the same syntax that I covered in the shared pointer video, and then a weak pointer is just initialized using the shared pointer. And the weak pointer has a similar syntax. So you have the weak underscore pointer class template, which here I'm initializing, instantiating with an integer because I'm pointing to an integer object. So let's take a look at what would be the pointer count after I create my weak pointer. Let me run my code. So as you can see, the pointer count is still 1, even though a weak pointer is pointing to the same object. So this is the expected behavior. How do I access the value pointed to by a weak pointer? Is this going to be possible? No. As you can see, the IDE has flagged an error. That's because a weak pointer could be pointing to an object which has already been destroyed, and the weak pointer would not have any knowledge about that. So the weak pointer cannot be used to access an object directly, and you have to use a function called lock on the weak pointer, which will return a shared pointer to that object. So in other words, you're checking to see if that object is still being referred to by a shared pointer before you can access it using a weak pointer. So let me put this down in code. I'm going to create a shared pointer sp2, and I'm also going to say, let me do this. I'm going to initialize sp2 to my weak pointer, and I'm going to call the lock function on it. And now I'm going to check the value. The value pointed to by sp2 and wp is, I can dereference my shared pointer in the usual way. Let me also check the pointer count at this point, because you have an additional shared pointer which has now been created and is pointing to the same object in memory. Let me correct that. Let's see what the output is going to be. So as you can see, the value pointed to by both sp2 and the weak pointer is 92. And since that new shared pointer has been created, our pointer count has increased to 2. And that's what you can see here. So as you can see, the weak pointer has no impact on the reference count. So let's try now resetting the first shared pointer. So how would you do that? You just say sp.reset. And let me do the same thing now. I'm going to say, let me check the pointer count. Let's see what our output is going to be. So let me differentiate this by saying this is 1, and I'll make this 2 so that we know that we're actually looking at different set of lines. So as you can see, the pointer count has dropped to 0 because SP no longer points to that specific object in memory. But SP2, the second shared pointer, has not been reset. So SP2 is still pointing to the object, and that's why the pointer count is 1. And we have our weak pointer, which is still pointing to the same object in memory. Even though the weak pointer was initialized to SP, it's still pointing to the same object. So you can actually use WP to obtain a use count. And at the end of the day, all that we need to know is like how many shared pointers are pointing to that object in memory. And we have our answer. It's 1. So let's next try to reset the second shared pointer. Let's do the same thing. And let me make this 3. So once we reset this, our pointer count should go down to 0. Let's take a look at what happens. So as you can see, the pointer count is 0 because no more shared pointers are pointing to that object in memory. So even the weak pointer, even though the weak pointer, we haven't actually reset the weak pointer. The weak pointer is still probably pointing to that object in memory, but the pointer count is 0. So that object has now been destroyed. So how do we ensure that that object has been destroyed? Let's do the same thing. Let's, in this case, we should be able to access, let's say, we say a shared pointer, integer, and we say sp4. Okay, and let me do the same check. sp4 is equal to wp dot lock. I'm just going to put, I'm only just going to check. So the pointer, the shared pointer is still pointing to valid memory. Let's see what happens. So I'm going to set a breakpoint here and let's hope it comes here. Okay, so if this is going to execute only if wp.lock returns a shared pointer, a valid shared pointer. Otherwise, if no valid shared pointer is available, that would mean that the memory has been destroyed. Okay, the shared pointer has not been initialized. So let me set a breakpoint here as well. Let's see what happens. Okay, and as you can see, memory has been released. So naturally, when you call lock on the object, there are no more shared pointers pointing to that object in memory. So that would mean that that object has been destroyed. So naturally, we are not able to obtain any shared pointer to that memory because all the shared pointers have been destroyed. And when all the shared pointers are destroyed, that object in memory also gets destroyed. So that's the reason why we cannot obtain any more shared pointers to that memory. And as expected, execution comes to this line. So the shared pointer has not been initialized. So there you are, a short introduction to weak pointers. I would encourage you to take a deeper look into weak pointers and see where they could be used. But they are a very useful concept and they can actually come in useful when we are trying to use companion classes. Thank you, and I'll see you in the next video.